Hi, this is Jorge from 37signals. So today I'm going to talk about how we architect our Rails applications. So last week was a special week because we launched Fizzy. Fizzy is our take on a Kanban tool. We launched it last week. The reception has been phenomenal. And something that made the launch very special is that for the first time we released the source of the service as an open source project. You can check in GitHub at basecamp /fishy. So you can clone the project, you can check all the history of commits, pull requests, everything is there. So I'm going to talk about some topics I've written about. If you go to dev37signals.com, you will find our dev blog, and there you can find the Code I Like series, which is a series of articles I wrote about all these topics. The central one is Vanilla Rails is Plenty, and there are other articles like touching or expanding on different aspects of the whole idea. When we talk about vanilla Rails, we actually refer to two things. One thing is our preference for not using third-party dependencies and going with Rails defaults. So, for example, we go with Rails view helpers and templates instead of view components, or we prefer Minitest to RSpec. That's one side of the equation. The other side of the equation is that we, architecturally speaking, we don't add new artifacts to what Rails and Ruby already provide when architecting our applications. Okay, so I'm going to focus on this latter side of the vanilla Rails equation. And well, since Fizzy is open source, like it's a great opportunity to discuss these topics. Looking at actual code and actual interactions and seeing how the application works. So I'm going to show like different parts of the application to make different points. So I'm going to start with the first one. For the first one, let me open the inspector tools. I'm going to show you how to drag. I'm going to drag a column from, this is running locally in my box. This is the cloned project from GitHub. I'm going to drag a card from one column to the maybe column, okay? And I want to show you what happens, okay? So this is sending like a post request to this endpoint that I'm going to open. So this is like dropping the card number 7 at the string column. That's what the resource is representing. If we go to the code base, I'm going to open that controller. Oh, sorry, it's not here. It's here. Streams controller inside drops. Okay. So I wanted to open this file. Okay. So from an architectural point of view, and by the way, this is an approach I've learned at 37signals. Okay, so this is the credit should go to David and other amazing programmers in the company, such as Jeffrey Hardy. I'm just trying to articulate what I understand the 37signals approach is. And the 37signals approach is not that radical or revolutionary. See, the 37signals approach is about placing the domain model at the center. Okay, so the domain model of your application is the central part of your application. And this is the core idea in domain-driven design, the movement and the paradigm that was popularized in the early 2000s in the book Domain-Driven Design by Eric Evans. I know that book had a tremendous influence on David back in the day because it's a book he often recommends. And that's what the book recommends, like make the domain model the central part of your application, meaning that you should put most of your effort on making that your code evoke the problem you are trying to solve, right? So in this case, this is a Kanban tool, so we try that our domain model reflects like the behaviors and the nouns we are using when we are discussing the product. So if you make the domain model the central part of your application, a key question is, how do you connect the external world with your domain model? So that's what in a Rails application, that's a question that you can answer at different parts of the application. The most typical part are Rails controllers, right? In a Rails application, Rails controllers are what connect like web requests with your application. So if you check our Rails controllers, you will normally see like very thin controllers exercising directly our domain model, invoking some business logic that you need to invoke to satisfy the needs for the request. So in this case, for example, in this case, we are dropping a card in a column. So you will find this is the business logic we are exercising. We are saying, card, send back this card. We are sending the message, send back to triage to this card. Okay? So that's what you will find in most of our controllers. Well, another typical scenario is more simpler scenarios. Like for example, if we go to the comment controller, so when you, for example, when you create a comment in a card, or when you update a comment in a card, you will find like, this is like pretty vanilla scaffolding Rails code. We are just updating or creating the record directly, which totally does the job when the interaction is as simple as that. So if you want to store some data in the database, some record in the database, totally fine to use active record to just do that. But it's quite often the case that we need to do something more complex. So in that case, we want to see that domain logic encapsulated in the domain model, and we exercise it directly from the Rails controllers. And this is the subject of, in my opinion, a controversy that is not really justified, which is like the whole debate about service objects. So, okay, application service objects. And I think I think it shouldn't be as controversial, because essentially, I mean, if you go to DDD and if you use application level service objects properly, so the idea of a service object is that you build this application layer that connects the external world with your application. Okay, so that's exactly the role that Rails controllers fulfill, right? But domain-driven design was written before even Rails existed, so its proposal was to use service objects, and service objects, in theory or in the original proposal of DDD, should do exactly what we are doing here. They should orchestrate how you orchestrate domain entities to satisfy your business logic needs at a high level, or also they should contain like infrastructure code, such as, for example, persistence. In the case you are separating the persistence concerns from your domain model, so the application layer is in charge of dealing with that persistence. So let's write this in code for a second, because I want to make a point that I think is important. So imagine that instead of sending the message send back to triage, we were using a service object here. So I could say something like, I don't know, card send back to triage. Okay, something like this. I'm creating a new service object send back to triage, and I'm invoking it on the card. I'm going to create a service object. This is helping me a bit. I don't want this. Imagine that I create a constructor for that, and now I'm going to write the call method. Okay, see, like the LLM is completing that and kind of enforcing the point I want to make. If we were using a service object in the way DDD proposes, you should use a service object, it would be like this. So we would have replaced the single line for a service object that invokes that single line, because service objects are not meant to implement your business logic. Service objects are meant to orchestrate the entities in the domain model that implement your business logic, which is completely different. Okay, so you want your Rails controller to remain thing, and you want your service objects, if you are using them, to remain thing. Okay, that's why I don't really understand the controversy, or I don't really understand how you would justify the service objects are such a life-changing idea, right? Because they are fulfilling the same role that Rails controllers are already fulfilling, which is orchestrating at a very high level what your domain objects do. Now, if you were not using Active Record and you were using an alternative approach to Active Record where persistence is completely separated from your business, your domain model, then yeah, here you would have a card repository or data access object when you say, okay, save me the card, and maybe the framework you're using is taking the changes in memory or whatever, and you will persist them like that. That's a whole different discussion that I might touch on other video. We use Active Record. We don't need that. In our case, with this approach, if you're using Rails controller like this, service object, in most cases, are boilerplate code, because you are just wrapping one line of code or 2 lines of code or 3 lines of code with a whole class to achieve not much benefit. But if that's your thing, I respect it. Please use them. We don't, because we care about boilerplate. We care about reducing solutions to its essence, and I think this is like a worse design and worse overall quality. But it's not such a big deal. Okay, what's the big deal with service objects? The big deal with service objects is when you propose to use service objects to contain your domain logic. Okay, so if we went here to the move back to triage method, this is not finding it. 1 second. It's in triageable concern. It's here. Okay, send back to triage method is here. I don't know why RubyMine wasn't navigating to it. So yes, so if you take this code and you say, okay, the service object is going to implement that code, right? So we are going to do this in the service object, and of course, because we are using service objects, instead of sending the message resume to the card to make sure it's not postponed, we are going to say card, I don't know, resume. Okay, I'm going to invoke that service object too. So suddenly, if you do that, which surprisingly is the advice I see service objects defenders advocate for over and over, which is implement your domain logic, your business logic, in the application layer of your application, then you are making your domain models, your domain entities, you're making them empty regarding behavior, and you are making them data holders, which is a problem which should not be, this should not be controversial, because this is a problem that has been known for years. It's a problem that was highlighted by Eric Evans in the original DDD book. I've seen this problem discussed in every DDD book I've read. Martin Fowler wrote a very famous seminal article called Anemic Domain Models in 2003, I believe, before Rails was even published, and they talk about this problem because many folks end up doing this, and if you do this, you suddenly are opening up a full can of worms in terms of design problems, because this is a poor design. Instead of having a proper domain model, what you now have is a very flat, long list of small operations where you either don't reuse code or you create a lot of coupling with between service objects to satisfy your domain needs. It's going to be very, very messy. So yes, at least I think it's important that at least if you want to use service objects, at least you should have in mind what's the idea with service objects. And the idea is not implementing your business logic. It should be orchestrating like 1, 2 domain entities, 3 domain entities to perform some operation. Now, in our case, as I said, we don't do this. We just do things. We just interact with the domain model from the controller. In this case, is one line, which is the most common case, along with what I show you in the comments controller case, like interacting with the records directly. In some other cases, like for example, when you in the boards controller, I was looking today. Sorry, not here. Boards controller here. I was looking today for examples of controllers like doing more than one line of code on the domain model. This is one of them. So when you update a board in Fizzy, you update the board params and then you invoke this revise method on the accesses association to grant and revoke permissions for the list of users you submit with the form. In this case, it's a controller. It's 2 lines of code. The important thing to me is that it's exercising domain logic about how to review permissions at the domain level. Now, if you want to do this here, for us, it's totally fine. If you want to extract a service object with these 2 lines of code, that's still fine. If you want to create a form object to do this, that's fine too. But please, don't advocate for implementing the domain logic in service objects. That's I think something, especially the folks that don't have much experience and are following the advice of service objects are the solution to all your problems. They are not. They actually, if you don't know how to use them, I think you are going to end in a worse place that the place you started at. So in our case, controllers exercise the domain models directly. Sometimes, I was going to say just another example, which is a sessions controller. In this case, so there is a path here where we are creating a new sign up in the system. And to do that, we are invoking this sign up object, where we invoke this create identity to create an identity in the system so that you can, that's actually like creating the user in the system. So this is not an active record object at all. Like we use a lot of plain Ruby objects, so we don't discriminate between active record objects or regular plain Ruby objects. But in this case, the point I want to make is that sign up is not, it's not a domain entity, it's not identified, it's more like an operation, a domain operation that we want to satisfy, that we can't satisfy sending a message to an entity. In that case, it's totally fine to create this will be like a domain service in DDD, but it's totally fine to get those objects in place. We don't use the term service. We don't call them sign up service, and we don't have methods like call. We prefer to use more semantic terms like sign up dot create identity. That sounds better for us. But other than that, yeah, we are using services. If we have to represent a domain operation that doesn't fit in an entity, we create an object for that, and that's kind of a service if you want. But what you get are controllers with little code orchestration or orchestrating domain level behavior at a very high level. That's our what we try to do. And the most typical case you will find in our controllers is this. Okay. So now, if you go with this approach, one problem some people complain about, and rightfully, is that, hey, but if we place a lot of behavior in our models, there are certain models that are going to be so big, doing so many things. They're going to violate the single responsibility principle in so many ways that this is going to be a maintenance hell. Okay, and in that regards, I can share some techniques we use. So the first technique I want to talk about are concerns. Okay, so concerns. If we go to this send back to triage model, we can see that that's in a card triageable concern, which is in the card folder in the models folder. So if we open the card model, you will find the triageable concern there, right? The triageable concern there. So what we are doing, so we use concerns in two ways, okay? In our code base. One way is like this case we are showing here. We use concerns to compose traits or roles in certain domain models to organize the behavior corresponding to those traits or roles, to organize those behaviors in cohesive units, okay, that are contained that sliced of business logic for that domain entity. So that's one way in which we use roles. So for example, here in a card, we can find that a card is postponable. So if you go to that concern, you will find, well, in this case, scopes and an association, certain methods that are related to postponing or resuming cards. If you go to the triageable concern we were at, those are, well, the same association, scopes, methods that are related to this slice of functionality. And the first thing you get by doing this, I mean, there is an obvious advantage, which is that you can organize large API surfaces in smaller units of code that they are easy to maintain and reason about. So for example, if I can go to the triageable test where I have the tests organized for this trait of cards of being triageable, that's an advantage. On a higher level, a big advantage is that you get this high level module cohesion in your code. So by doing this, I can go to this triageable concern and I get things that belong together in the same file. So for example, I can get the triage scope that is saying, oh, this is query the cards that are active that have a column. And then I have this query method triaged that is checking the same thing. So if I want to change this condition, I want to change this condition. So it's very, very handy that they are together, right? It makes sense for me as a human who is trying to alter the system or trying to understand the system. That's cohesiveness of the kind you want to see in your code base. So that's an advantage. Another advantage is that they are very lightweight. It's a matter of you don't need to create new hierarchies of objects or new instances. You don't need to define this role object that wraps the original object to decorate it. This is lighter than that. If I go to the card object, I have like this triageable concern, which is a single file, and it's injecting this behavior relating to being triage. Things are organized. It's easy to understand. It's cohesive. We use them a lot. So that's one way we use concerns. Another way we use, by the way, this is not to mean that we organize all the behavior in all the classes with concerns, or that you can place behavior in the main class, right? So in this case, in the case of card is like board. These are central entities in our domain model. So they have a lot of behavior and they have a lot of concerns. In other cases, you won't find this. I don't know. Well, user is another kind of central part or central entity. if I go to, let me check another, for example, identity. Identity is only mixing two concerns. It's totally fine to have like a main body of methods in domain models by default, and using concerns for kind of secondary traits or relevant traits, but that are not that much related to the core of what the entity model is trying to do. But in the case of central entities, you will find a lot of concerns because they are very, very handy, when you have a lot of methods to try to keep those organized, okay? But, so this is a case of using, one way we use concerns. Another way of using concerns is the original mixing notion in Ruby, which is a way of sharing code among classes. So we use concerns in that way too. So if we went to the streams controllers that we were originally at the controller layer, we have this card scope concern that we are using at many places. As you can see, we are using card scope, this card scope in many controllers, and this is essentially injecting this before action to set the board, to set the board and to set the card, so that you can use the card directly by just including the concern. That's one way of using them. We also do this at the model level, but not, this is, we don't do this as much at the model level, but we definitely do. So, for example, I'm going to show you something here. If I grab a card and I say, hey, JSON, and I send a message for JSON. Oh, the problem is that, let me clear these notifications because the notification was already there. So JSON, hey there. So yeah, you can see how this was this showed up here, right? So why that happened? How this happened, right? If I go, so that's submitting the comment. We have a system in place that is extracting the mention and creating the mention model. This mention model includes this notifiable concern, which is the second code reuse scenario I was talking about. If we check the notifiable concern, it's in the concerns folder, and we can find that events and also mentions and events are two notifiable objects. Okay. Now, sometimes when folks talk about concerns, they kind of oppose concerns to other techniques as if they were opposing alternatives. Like, should you use concerns or should you use object composition? Should you use concerns or should you use, service objects? The thing is that concerns are a fantastic way of organizing like large API surfaces in a cohesive way, but concerns play very well with object orientation techniques. So, for example, the fact that you use concerns is not an obstacle to building systems of objects, for example, that you can compose to satisfy one of those high-level methods that you are exposing through your domain entities. So you can totally combine object-oriented programming, object composition with concerns, and actually that's what we do. I'm going to explain this with a couple of examples that are also tied to using callbacks in this case, coincidentally, so we can talk about callbacks too. So this notifiable concern that we were using to reuse code is inserting this after create commit notify recipients later callback. So this is invoking this method, and this method is invoking this job. If we go to the job, we can find again, this is like a controller to us. This is exercising the domain model from the boundaries of the system, in this case to execute some domain model logic asynchronously, but it's the same. We want to see like a thin job just invoking some domain entity code. That's what what you would normally find in our jobs. So it's kind of the same. We are exercising the domain model from the boundaries of the system. Same if we were in a Rails console. Same if we were in a script. That's what we want to see. So we are getting a notifiable object and we are sending the notify recipients message. Now, if we go here, you can see how the point I want to make is that here we don't have like, I don't know, 20 private methods or, you know, a lot of lines of code invoking this notification system. Instead of that, this concern is passing that message of notifying recipient, is delegating the work to a notifier entity, a notifier object that is going to take care of that. And if we go to that for message in notifier, this is a class method that, depending on the source of the notification, is creating a specific notifier object. Because we, for example, if we go to the mentions notifier, it's a notifier, so it inherits from notifier, but it's overriding the recipient's method. And the recipient's method is like a template method, okay? Template method that the parent notifier class defines and expects when it's notifying folks. It's expecting this recipient's method to exist, and that recipient's logic changes depending on the kind of source you have for the notification. So we model that system like that. So you have like a system of 4 objects, a design pattern, which is the template method. You have a hierarchy of objects, and everything is hidden behind this high-level interface that we are organizing with a concern. So both legs are important, okay? Concerns for organizing the code and proper object orientation. Object-oriented techniques and patterns for trying to get the code organized, understandable, maintainable. All right. So another example I can show is I wanted to say to share a similar, a different but kind of similar example, which is the stallable concern. So in Fizzy, a card can be stalled. And for a card to be stalled, it means that we have detected an activity spike at some point, and then the card went cold. Okay, nobody commented, there was no activity. So we consider that card was stalled, and we show a bubble in the card indicating that. Okay, that's part of our features and of our domain logic. And how do we implement that? So in the stallable concern, we are using a callback again, and when a card gets updated, we detect activity spikes later. So we detect these activity spikes and we record an activity spike when it happens. Again, depending on when the activity spike happened, we show that bubble. That's how the system works. So what I wanted to show is that, this is invoking a job, same case. This job is passing this message, detect activity spikes to the card, and here again we are using object composition. We are delegating the work itself to its own specialized class, which is this activity spike detector. And if we went there, we will find the logic. So we will say, an activity spike happens when the card is entropic and multiple people commented, or the card was just assigned or was just reopened. We used to have like a more involved logic here, but we simplified it at some point. Doesn't matter. The case is that the point I want to make is that using concerns does not mean that concerns are the silver bullet that are going to solve all your modeling needs. You really need to use like additional systems of objects to keep your code maintainable in most applications. Because certainly you don't want to see concerns like with thousands of lines of code and having chunks of methods implementing different slices of functionality. That's not the idea. Okay, the idea is organizing large API surfaces into cohesive modules, and those modules serve as the entry to either very simple logic or systems of objects that are fulfilling the task. Okay, that's I think the whole idea behind of I mean that's the problem with this is that it's hard to offer recipes about how to proceed, because we are balancing a lot of things when we are designing software. Designing software is very hard, but I think that's a good general idea. Okay, I can share. All right, and in both cases I touch on callbacks. Callbacks are one of those Rails techniques that are, again, controversial, because it's true that with callbacks you can create problems in your code base. Callbacks introduce indirection, so you don't want to orchestrate like complex flows with callbacks. Those are, I mean, there is certainly a way where you can shoot yourself in the foot by using callbacks if you use them to orchestrate a lot of things, and you can find yourself in complex debugging sessions trying to understand what's going on. So that's definitely a problem, but the conclusion there is not never use callbacks. Is that the conclusion is use callbacks when they are the best tool for the job. And in this case, if you think about it, like, forget about Rails, forget about, I don't know, forget about the specifics of the technology. Is if as a human you're trying to say, oh, I want to detect an activity spike whenever the card changes, or oh, I want to notify folks whenever a notification whenever a notifiable object changes and it's subject to have generated some notification, then callbacks is a perfect fit. I mean, it makes sense to you as a human to say, oh yes, whenever this model changes, I want to inject this logic. So if I introduce some new way of commenting on a card, the activity detection system is going to keep working. So that's a good design, right? So callbacks are fantastic when they are the right tool, and I definitely encourage you to consider them and have them in your toolbox. Actually, like, for example, I was thinking right now that if we go to the triageable concern, in this case, so when you send, this is the original, I mean, the first example I shared, when you send a card back to triage, we are tracking the event. This is explicit code. So in this case, we are tracking the event with an explicit invocation. We are not using callbacks. So callbacks, the fact that we have callbacks available does not mean that we use callbacks all the time, okay? We are mindful about when to use callbacks, but when they are the right tool, they are an amazing tool to have and to leverage. So I definitely encourage you to use them. Okay, so I think there are. I had a bunch of questions in the. I asked in Twitter in X if some people had questions that I wanted to touch on, and I think I'm going to record a video for answering those. Another video, a different video, because this one is taking already quite a bit of time. So I'm going to stop here. I hope you like the video and I hope you find it useful. Thank you so much for your time. See you.